The concept of repeating the same frequency is known as dash, and the cells using the same frequencies are known as dash. Option A, cell splitting and adjacent cells. Option B, frequency reuse and adjacent channel cells. Option C, frequency reuse and co-channel cells. Option D, cell sectoring. We know that in mobile communication or cellular communication, the available spectrum or the frequency spectrum will be very limited. To serve many users, the same frequency channels are to be reused in different geographical locations that are far apart so that they do not interfere with each other. This concept is actually known as what? Frequency reuse. So in the question, the concept of repeating the same frequency is known as what? It is known as the frequency reuse. And also, the cells which are using the same frequency channels, they are known as the co-channel cells. Since they operate with these identical frequencies, they must be separated with the sufficient distance in order to minimize the co-channel interference. So, the cells which are using the same frequency is known as what? Co-channel cells. And also we discussed the concept of repeating the same frequency is known as what? It is known as the frequency reuse. So, the answer is option C. So, here it will come what? Frequency reuse, and here we can move on to the next question. If D is the distance between two co-channel cells and R is the cell radius, then D by R is known as option A, adjacent channel interference reduction factor, option B, co-channel interference reduction factor, option C, adjacent and co-channel interference reduction factor, option D, none of the above. In cellular systems, the D will give the distance between the center of two co-channel cells and R gives the cell radius. Then this ratio D by R, this D by R ratio is known as the co-channel reuse ratio or co-channel interference reduction ratio. This ratio, this D by R ratio, it actually determines how much co-channel interference is reduced. If D by R ratio is larger, this means that the cells are far apart. That is, the D value is high. So then the interference will be less. So this is the significance of D by R ratio, and this D by R ratio is known as the co-channel interference reduction factor. So answer is option B. Now we can move on to the next question. In an n cell reuse pattern, the equation of n is given by n is equal to I plus j the whole square, n is equal to I square plus ij plus j square, n is equal to I plus j plus 2j, n is equal to j plus 2i. Actually, we know that in cellular concept, we are usually using the cells which are having the hexagonal shape. Cells having the hexagonal shape we are using. Then this n gives the cell reuse, number of cells in the cell reuse pattern. So that is given by n is equal to I square plus ij plus j square. And this equation defines the cluster size in the hexagonal cellular layout. So this is the equation of n. N is equal to I square plus. Next question. The macro and micro cells are available in option A, handoff, option B, cell sectoration, option C, co-channel cellular region, option D, umbrella cell pattern. This figure, you can see, this is the figure of an umbrella pattern. This is an architecture of umbrella cell pattern. Here, the large umbrella cells are used for handling the high-speed traffic, and the small micro cells, they are usually used for the low-speed traffic. So, in this architecture, we can see both the macro cells as well as the micro cells. So, we can say that the macro and micro cells are available together in which pattern? It is seen in umbrella cell pattern. Okay, this large umbrella cells are used for high speed traffic, and small micro cells are usually used for low speed traffic like pedestrians, etc. Now we can move on to the next question. Who has the responsibility of building and system maintenance function in cellular system? Option A, base station, option B, PSTN, option C, MSC, option D, mobile system. We had studied that the responsibility of building and maintenance system is usually handled by the MSCs. MSCs in cellular systems. So the answer is option C. MSC means it is the mobile. MSC means it is the mobile switching center. Mobile switching center. MSC is the mobile switching center. They are usually handling the billing functions, then system maintenance and management, call routing and switching, then mobility management, etc. So the billing and system maintenance is usually handled by MSCs. Now we are moving to the next question. What is MIN? Option A, subscriber's telephone number. Option B, paging message. Option C, traffic request number. Option D, mobile internet. MIN means mobile identification number. MIN means it is mobile identification number. It is actually a 10-digit number, which is usually, it is and also a unique number, which is being used in cellular networks uh, during the time of call setup, authentication, and registration process. And it is actually the subscriber's telephone number. So MIN means it is the mobile identity. What is the shape of the cell present in cellular system? Option A, circular. Option B, square. Option C, hexagonal. Option D, triangular. Usually in cellular systems, the coverage area of each cell is usually represented by using the hexagonal shape because they provide the efficient coverage without gaps, minimal overlap between the adjacent cells, equal distance to the neighboring cells, and also simplified frequency reuse planning. So, the hexagon is the most practical geometrical shape for modeling the cell coverage. So, the answer is option C, hexagonal shape. Next question, why the why the size of the cell is kept small in cellular network? Option A, increased capacity. Option D, decreased capacity. Option C, increased size of base station electronics. Option D, slow process of handoffs. The cell size is kept small in cellular networks mainly to increase the system capacity. Smaller cells means more cells can fit in the same geographic area. The frequency can be reused more often. More users can be supported simultaneously. So, thus reducing the cell size, we can increase the capacity of the cellular network. So, the answer is option A. Next question. The process of transferring a mobile station from one base station to another is dash. Option A, MSC. Option B, roamer. Option C, handoff. Option D, forward channel. The process of shifting an active mobile station from one base station to another as the user moves is called handoff or the handover. Sometimes it is called handover, but usually it is called as handoff. This ensures a continuous and uninterrupted call or the data session. So, the process of transferring a mobile station from one base station to another is known as handoff. It is option C. Why neighboring base stations are assigned different group of channels in cellular system? Option A, to minimize interference. Option B, to minimize area. Option C, to maximize throughput. Option D, to maximize capacity of each cell. In cellular system, neighboring base stations are assigned different groups of frequency channels to avoid the interference between the adjacent channel. This practice is a part of frequency reuse. Actually, it ensures minimal co-channel and adjacent channel interference, clear and reliable communication, and also the efficient utilization of spectrum without the signal clashes. So, the answer is option A. This is usually done to minimize the interference. Question. Why is the shape of cell is not circle? Option A, omnidirectionality. Option B, small area. Option C, overlapping regions or gaps are left. Option D, complex design. Using a cellular shape of a cell in a cellular system is usually impractical because the circles cannot tile the plane without leaving gaps or causing the overlaps. This would lead to coverage holes or excessive interferences. So, usually we are using the hexagonal shape instead of the circular shape as it is efficiently covers an area without gaps or overlaps. So, this is the reason why we are not usually using the shape of the cell as circle. So, the answer is option C, that is the overlapping regions or gaps are left. So, the answer is option C. Which type of antenna is used for center excited cells? Option A, dipole antenna. Option B, grid antenna. Option C, sectored antenna. Option D, omnidirectional antenna. For center excited cells in cellular systems, the base station is to be located at the center of the cell. That is, the antenna needs to be radiate equally in all directions to cover the cell uniformly. So, an omnidirectional antenna, it will provide 360-degree coverage. So, we are usually using an omnidirectional antenna for a center excited cell. The answer is option D. Next question. For a cellular system, if there are n cells and each cell is allocated k channels, what is the total number of available radio channels S? Option A, S is equal to k into n, B is equal to S is equal to k by n, C, S is equal to n by k, D, S is equal to k raised to n. In the question, they have given that for a particular cellular system, there are n number of cells and also each cell is being allocated with k number of channels. So, the total number of cells radio channels available is equal to k is equal S is equal to k into n, where n is the number of channels allocated and n is the number of cells. So, the total radio channels available is equal to k into n. K is the allocated channels per cell and n is the number of channels. So, the answer is option A. What is a cluster in a cellular system? Option A, group of frequencies. Option B, group of cells. Option C, group of subscribers. Option D, group of mobile systems. In a cellular system, a cluster is a group of adjacent cells in which all the available frequencies are used exactly once. So, we can say that the cluster in a cellular system is actually what? The group of cells. Clusters are the basic unit of frequency reuse, helping to maximize the spectral efficiency while minimizing the interference. So, actually a cluster represents a set of cells that together uses all the available spectrum frequencies before this patterns is being reused. So, the cluster means it is actually a group of cells. Next question, what is the frequency reuse factor for n number of cells in a system? Option A, n. Option B, n square. Option C, 2n. Option D, 1 by n. The answer is 1 by n. The frequency reuse factor for n number of cells in a system is 1 by n. Channel assignment strategy, each cell is allocated a predetermined set of dash. Option A, voice channels. Option B, control channels. Option C, frequency. Option D, base stations. The answer is frequency. That is, in a fixed channel assignment strategy, the cell is allocated with a predetermined set of frequencies. With this particular allocated frequencies, the traffic is being maintained. That is, the answer is option C, that is frequency. What happens to a call in a fixed channel strategy if all the cells in the cell, if all the channels in the cells are occupied? Option A, queued. Option B, crosstalk. Option C, blocked. Option D, delayed. We know that in fixed channel assignment strategy, a particular number of channels will be allocated to a fixed cell. If the traffic is more than that of the allocated channels, then what will happen? Since there are no available channels in the cell, then the calls will be blocked. So answer is option C.